Welcome. My name is Noel Pinkerton, Principal Advisor, Occupational Hygiene from the Office of Industrial Relations. Before we begin, we respectfully acknowledge the traditional custodians of the land which we meet today. We also pay our respects to elders past and present, and extend that respect to Aboriginal and Torres Strait Islander people. Industrial Relations Minister Grace has approved Queensland's new Managing Respirable Crystalline Silica Dust Exposure in Construction and Manufacturing of Construction Elements Code of Practice 2022. The new code, commencing in Queensland on the 1st of May 2023, is Australia's first silica dust code of practice for the construction industry. It applies to all construction work and the manufacturing of construction elements, including materials such as bricks, blocks, tiles, mortar and concrete. The code outlines how duty holders can meet the existing requirements of Queensland's work, health and safety legislation by eliminating or minimising exposure to respirable crystalline silica, or RCS, at work by using tried and tested control methods that prevent silica dust from being generated or being released into the air, including water suppression and on-tool dust extraction, using appropriate respiratory protective equipment to safeguard at-risk workers, using exposure data from air monitoring to check how effective dust controls are, providing health monitoring to at-risk workers with clearly defined triggers of testing based on the level of risk, consulting with workers as well as training, education, instruction and supervision of workers. The code was developed in close consultation with workers, employers and technical experts across Queensland, building on international best practice to ensure silica dust is managed safely and workers are protected in the construction industry and the manufacturing of construction elements. The code incorporates all the elements of the work, health and safety legislation which apply to the managing risks of exposure to respirable crystalline silica. The Managing Respirable Crystalline Silica Dust Exposure in Construction and Manufacturing of Construction Elements Code of Practice is an approved code of practice under Section 274 of the Work Health and Safety Act 2011. An approved code of practice is a practical guide to achieving the standards of health, safety and welfare required under the Work Health and Safety Act and the Work Health and Safety Regulation 2011, or the Act and Regulations. The code incorporates all the elements of the Act and regulations which apply to managing risk of exposure to respirable crystalline silica, or RCS as it's commonly known. Under the Act and regulation, a person conducting a business or undertaking, or PCBU, has a duty to ensure, so far as reasonably practicable, the health and safety of each worker while at work. This includes a legal duty on the PCBU to manage risks to health and safety associated with using, handling, generating or storing a hazardous chemical at work. This includes RCS. The PCBU has other legal duties that determine how they must manage the risk of exposure to RCS, including but not limited to duty to make sure no person at the workplace is exposed to RCS at a level above the workplace exposure standard, duty to make sure air monitoring is carried out if they are not certain on reasonable grounds the workplace exposure has been exceeded, or monitoring is needed to determine if there is a risk to health. Duty to make sure health monitoring is carried out if there is an ongoing significant risk from a worker's health from exposure to RCS. The code outlines how the PCBU can manage risks associated with RCS at the workplace in a way that meets all of the above legal requirements. The code applies to construction work or the manufacturing of construction elements when it involves both the use of materials that contain 1% or more of crystalline silica and tasks that generate dust containing RCS or make RCS airborne. The definition of construction work is set down in Section 289 of the regulation. This includes work in commercial construction, residential construction, civil construction and tunnelling. The manufacture of construction elements applies to the manufacturing of elements for use in construction work regardless of where the manufacturing is undertaken, not just limited to work on a construction site. The code covers the manufacture of construction elements or materials including, but it's not limited to, cement, concrete and aggregates including precast concrete products, such as fibre cement sheeting, bricks, tiles, blocks, pylons and pavers, grout, mortar, asphalt, sand and stone, wall panels and geosynthetics. The code does not cover manufacturing of tools or plant for use in construction. Queensland workplaces in the mining and resources industry, including quarries, which fall under the legislation that are managed by Resource Safety and Health Queensland. The code does not apply to the engineered and natural stone benchtop industry. That industry is covered by the manufacturing respirable crystalline silica dust exposure in the Stone Benchtop Industry Code of Practice 2019. Many common materials used in construction and manufacturing of construction elements contain crystalline silica. For example, bricks, concrete, autoclaved aerated concrete, natural stone, for example granite and sandstone, and fibre cement sheets. Common construction and manufacturing materials that contain less than 1% crystalline silica include, but are not limited to, wood, glass, metals such as iron, steel, copper and aluminium, and most plastics. To find information on the crystalline silica content of a product, check the information provided by the manufacturer, supplier or importer. This can be from sources such as technical sheets, a safety data sheet or product information labels. Or, if not readily available, contact the manufacturer, supplier or importer for the information, or have the material tested by a NATA accredited facility, or if the PCBU is unable to find out whether a material does contain 1% or more of crystalline silica, the PCBU should presume that it does. Construction work that involves earth moving, such as digging trenches or tunnelling, can also involve a risk of RCS exposure, as many common materials found underground contain crystalline silica, such as most rocks, sands and clays, granite and sandstone. To determine if the material contains 1% or more of crystalline silica, a geotechnical report, a petrographic test or bulk material analysis are available methods to find out the content of the materials present. PCBUs must adopt a risk management process to eliminate exposure to RCS so far as reasonably practicable, or if it's not reasonably practicable, to eliminate exposure to RCS by minimising it so far as is reasonably practicable. To meet their health and safety obligations, PCBUs need to identify RCS hazards. This is covered in sections 4 and 5 of the code. Choose the right controls, covered by section 6 of the code. Monitor and review controls. This is covered in sections 9 and 11 of the code. The code outlines 2 methods for choosing the correct controls. Method 1 is using the controls table, or method 2, using exposure data to choose dust controls that work. Section 2 of the code provides flowcharts to help PCBUs work through the 2 methods and explains how they link to the duties related to air monitoring and health monitoring. Method 1, using Appendix 4 of the code, which outlines controls for a range of common tasks in construction and manufacturing of construction elements. The tasks are based on power tools and mechanised plant, as well as a number of housekeeping tasks that can generate RCS or make it airborne. For each task, the table outlines engineering or work practice control methods, the respiratory protective equipment or RPE for that task depending upon how long the shift is, if the task is done outdoors or indoors or an enclosed area, where health monitoring is required, if the recommended combination of control methods and RPE are used for that task, and they are used properly, the PCBU does not need to conduct air monitoring to assess the risk from that task. Method 2, using exposure data to choose dust controls that work. The PCBU does not have to use the recommended controls included in Appendix 4. If the PCBU does not choose to use the controls table, the PCBU must follow the hierarchy of controls outlined in Section 7 of the code. This means the PCBU must eliminate the risk. If eliminating the risk of RCS is not reasonably practicable, the PCBU must use higher order controls. These include substituting the hazard to eliminate or minimise the risk, isolating the hazard, or using engineering controls. If the risk of RCS exposure remains after using the above controls, the PCBU must use the following controls to minimise the risk: administrative controls and respiratory protective equipment. The dust controls, or a combination of controls, chosen by the PCBU must keep exposure of RCS below the workplace exposure standard. The PCBU must have an air monitoring report that provides statistically valid exposure data that shows the controls chosen for the task to reduce exposure to RCS to below the workplace exposure standard. Construction work carried out in an area that may have an atmosphere contaminated with RCS is high-risk construction work and will require a safe work method statement. For businesses that manufacture construction elements, PCBUs must plan the manufacturing of construction materials to identify sources of RCS and choose the right controls. The PCBU can prepare this plan as part of a WHS risk management plan or document, or they can prepare a specific RCS dust control plan. The plan for manufacturing construction materials should include information on how you intend to eliminate or minimise the amount of RCS being made and released into the air, prevent RCS being breathed in by workers, clean up any RCS in dust, wet slurry or other waste, provide facilities for workers to clean up after work. The requirement for health monitoring under this code is triggered when a worker has been doing jobs that, even when using higher order controls, generate enough RCS that RPE is needed to keep exposure below the workplace exposure standard, and the worker needed to wear RPE to work safely on 30 days or more in a year, or the PCBU is reasonably certain the worker will need to wear RPE more than 30 days in the next 12 months. Appendix 4 of the code is a controls table outlining recommended controls for a range of common tasks in construction and manufacturing. The tasks are based on power tools and mechanised plant, as well as a number of housekeeping tasks that can make RCS airborne. The example shown on the screen selects the use of a handheld powered saw. This includes quick cut saws and concrete chasers. There are two options of higher order controls listed in the second column. The top option is the use of water to suppress the dust, while the other option uses an on-tool dust collection system. While the higher order controls will reduce workers' exposure, there are times when a significant risk remains. When a significant risk remains, the use of RPE is required to minimise a worker's exposure to RCS. As can be seen in the column entitled Respiratory Protective Equipment, Minimum Protection Factor, or MPF, the minimum protection factor of the RPE is shown. This column is broken into 4 situations, depending upon the length and location of the task. When the work is conducted for less than 4 hours in a single shift, this total is accumulated throughout the shift, and when the task is done for equal to or more than 4 hours in a single shift. The other factor shown in this column is the location. An indoors or enclosed area refers to any area where, without the assistance of forced ventilation, the dispersal of airborne dust can be impeded and can build up in concentration. For example, work areas with only a roof that does not affect the dispersal of dust would not be considered enclosed. However, an open-top structure with 3 walls and limited air movement could be considered enclosed. Parking garages, pits, trenches and empty swimming pools may qualify as enclosed areas. Outdoors would be considered any workspace not covered by the definition of indoors or enclosed area. The final column in this table outlines when the need for health monitoring is triggered. If you're using the controls table in Appendix 4 to choose the right controls, you should make sure that RPE is used whenever the table states that it should be used. If you are not using the controls table in Appendix 4, to choose the right controls, you should make sure RPE is used when air monitoring has shown that the levels of RCS in the breathing zone of the worker exceeds the workplace exposure standard. The respirator should provide the required minimum protection factor, MPF. See the table from Australian Standard AS/NZ 1715 for further information. You should consider RPE maintenance requirements, including cleaning and availability of appropriate equipment and spare parts. To protect against airborne RCS, respirators need to incorporate a particulate filter. Particulate filters are classified and marked as P1, P2 or P3, with P3 providing the highest level of protection. P3 protection can only be achieved if the P3 filter is used with at least a full face respirator. All three classifications of filter are suitable to protect against RCS. Fit testing is required for all tight-fitting RPE provided by the PCBU to protect against RCS. Fit testing detects if air leaks into the respirator through gaps in the seal between the respirator facepiece and the face. It is an essential step in the RPE selection process and allows a PCBU to determine if the specific make and model of RPE is a suitable size, fit and comfort for the worker who is going to use it. Fit testing must be undertaken before the specific make and model of RPE can be used. Planning fit testing should form part of the review process for producing a safe work method statement or an RCS dust control plan. Quantitative fit testing is the preferred way to fit test RPE. In addition to ensuring a tight-fitting respirator has been successfully fit tested before it is first used, fit testing should also occur at least once per year whenever there is a change in the wearer's facial characteristics or features which may affect the facial seal, e.g. a large change in weight, scars or other wounds present, and each time a new make or model of tight-fitting respirator is used. Fit testing can be carried out in a range of settings, including mobile testing units, specialised facilities or in-house using the appropriate equipment. You should take steps to ensure that the person who carries out the fit test is appropriately trained, qualified and experienced, and has at a minimum the following competencies: knowledge of the respirators used for the fit test, knowledge of the fit test method, ability to set up all applicable equipment and monitor its function, ability to carry out the test and evaluate the results, and the ability to identify likely causes of fit test failure. Air monitoring involves testing air to find out how much of a harmful substance, such as RCS, is in the air. It is a proactive measure to determine how effective controls are and if a worker is adequately protected. The purpose of air monitoring for RCS is to determine the airborne concentration of RCS in the breathing zone of the worker. The breathing zone means a hemisphere of 300 millimetres radius extending in front of a person's face and measured from the midpoint of an imaginary line joining the ears. This will confirm if the work is adequately protected or if more effective controls are needed. Air monitoring must be carried out when the PCBU is not certain on reasonable grounds if the workplace exposure standard is being exceeded or not, or when air monitoring is needed to work out if there is a risk to health. In both of these cases, the purpose is to make sure that the worker is protected from exposure to RCS at levels that exceed the WES or if more effective controls are needed. A PCBU is required to conduct air monitoring for RCS if they are not certain on reasonable grounds if the workplace exposure standard has been exceeded. There are a number of ways a PCBU can be certain on reasonable grounds. Firstly, by using all the recommended controls for the task as specified in Appendix 4, including RPE if required by the table, or when you have statistically valid exposure data for the task that demonstrates the higher order controls you are using minimises workers' exposure to RCS below the workplace exposure standard without the need for RPE, or when you have statistically valid exposure data for a task that demonstrates a combination of higher order controls and suitably rated RPE. If the PCBU does not use the recommended controls for the task as specified in Appendix 4 and does not have statistically valid exposure data to demonstrate the controls they are using protect workers from exposure to RCS, they can't be certain on reasonable grounds and must conduct air monitoring. Air monitoring produces exposure data, which is a measure of how much of a harmful substance such as RCS is in the air. This exposure data can be used to work out how effective controls are. The PCBU is required to conduct air monitoring for RCS if they are not certain on reasonable grounds if the workplace exposure standard has been exceeded. A PCBU can use existing exposure data for the specific tasks and controls to be reasonably certain, so as long as the data came from air monitoring that meets the standards outlined in the code. This is to make sure the exposure data is statistically valid. Statistically valid exposure data sources could come from the manufacturer of the control or tools, an industry association, or an occupational hygienist. The duty is on the PCBU to be certain that the exposure data is statistically valid and that it is relevant to the task, controls, and conditions. If they are not, then they cannot be certain on reasonable grounds that the controls used are effective. If the PCBU is uncertain whether the existing exposure data is statistically valid, they should consult with a competent person such as a certified occupational hygienist. Air monitoring for RCS should include the establishment of similar exposure groups or SEGs and the development of a personal exposure sampling plan in accordance with EN 689/2018. That is representative of worker numbers, shifts worked, tasks performed and conditions at the workplace. Undertaking baseline personal exposure monitoring of workers in each relevant SEG and assessing the results using either the preliminary or statistical test methods described in EN 689 to determine if the workplace exposure standard is being exceeded. Undertaking periodic personal monitoring at the recommended intervals. All personal sampling should be undertaken in accordance with Australian Standard 2985/2009 with samples analysed by a NATO accredited laboratory. Static and real-time sampling methods can be used to assist with risk assessments, monitoring and working out the size of exclusion zones. However, they are not suitable substitutes for exposure monitoring. Static sampling can be used to measure area-specific dust levels and identify sources and causes of dust generation to enable the dust control efforts to be focused and prioritised. Static sampling is a valuable tool for assessing the effectiveness of process controls. For example, sampling before and after the implementation of controls so the effectiveness of those controls can be verified. Place static sampling points close to the sources of dust to assess the magnitude of dust levels. Location of static sampling points should be documented in sufficient detail so that measurements can be repeated. Real-time sampling uses a direct read-in device to measure dust concentrations and can be used in a variety of ways, depending on the functionality of the direct read-in device. Real-time devices can be used in conjunction with gravimetric sampling to detect changes in instantaneous dust concentrations or even peaks in dust concentrations. Real-time devices can also be used to give an indicative time-weighted average if collected in the breathing zone of a worker and the duration of sampling is representative of normal shift activities. It is important to note that real-time sampling cannot be used to assess compliance with workplace exposure standards. It can provide an indication of the effectiveness of the control measures in place. Air monitoring should be undertaken by a person who has acquired the knowledge and skills to carry out the task from training, qualification or experiences. Refer to the table on the screen. The AIOH website can be used to assist with finding a certified occupational hygienist. Appendix 6 refers to the minimum content for an air monitoring report. Air monitoring results should include more than just the worker's time-weighted average exposures to RCS. In order to provide usable information on the effectiveness of controls, properly assessed workers' exposure to RCS and to demonstrate compliance with this code and the WHS regulations. A PCBU must make sure health monitoring is provided to a worker carrying out work for their business when there is significant risk from exposure to RCS. Schedule 14 of the regulation lists the requirements for health monitoring for crystalline silica, including the type of health monitoring. Significant risk exists when the worker is undertaking tasks that require them to wear RPE. As such, the PCBU must provide health monitoring to a worker if, on 30 days or more in the previous 12 months, the worker has done tasks that involve materials that contain crystalline silica and that make RCS or disturbed RCS, and according to the code, the worker should have worn RPE for those tasks. For some jobs in construction and manufacturing, the PCBU can be reasonably certain that the worker will meet this trigger in the next 12 months. If a worker wears RPE for work and they are not required to by this code, this does not count towards the 30-day trigger for health monitoring. The 30-day trigger for health monitoring should be worked out using the following rules. If the worker is required to wear RPE by this code at any time during a day, that counts as 1 day of respirator use. It does not matter how long the RPE was worn for, including if the task takes less than 15 minutes. For example, if the code requires a worker to wear RPE while jackhammering concrete indoors for 2 hours, that would count as 1 day towards the 30 days. If the code requires a worker to wear RPE for 2 or more tasks in a day, this still counts as 1 day towards the 30. This 12-month period is not connected to a calendar or financial year. All that matters is that the 30 days counted takes place in 12 months or less. As the PCBU, you must make sure that any health monitoring is done by a registered medical practitioner with experience of doing health monitoring. The PCBU also must give workers and new workers information about health monitoring, consult workers on the doctor chosen to do the health monitoring, pay all costs related to health monitoring, provide the doctor with information about the worker including the work that the worker is or will be carrying out that has triggered the requirement for health monitoring, if the worker has started that work and how long the worker has been carrying out that work. After the worker has received health monitoring, the PCBU must take all reasonable steps to get a written report from the doctor on the results. The PCBU must provide a copy of the written report to the worker and provide a copy of the written report to any other PCBUs with a duty towards the worker. Workplace Health and Safety Queensland will need to be informed if the report has test results that suggest harm, the report has recommendations for remedy, and keep confidential records for at least 30 years after the report is made. In summary, the code applies to the construction and manufacturing of construction elements excluding stone benchtops, becomes effective on the 1st of May 2023. This code is a continuation of our commitment to control the exposure to RCS. Remember to follow the table in the code on engineering and work practice control methods and monitoring and the requirements for RPE. For more information about health monitoring, visit worksafe.qld.gov.au.